Hey everyone, welcome back to the channel. If you're here, you're probably eyeing that AWS Certified Security Specialty certification. It's one of the toughest and most rewarding AWS badges out there. Today, we're diving straight into the official exam guide for the SCS-C03 version. Whether you're just starting out or brushing up, stick with me. I'll walk you through the key parts in a way that's easy to follow so you know exactly what to expect. First off, quick heads up. As of right now, in December 2025, the current exam is the updated SCS-C03. The old SCS-C02 wrapped up on December 1st, and this new version brings some fresh focus on things like generative AI and machine learning security, plus restructured domains to better separate detection and incident response. If you're scheduling your exam soon, make sure you're prepping for SCS-C03. So what is this exam all about? The AWS Certified Security Specialty is designed for folks who have real responsibility for securing cloud solutions on AWS. It's not for beginners. This validates that you can effectively secure AWS products and services in the real world. Hang on, because this part's super important. The exam tests your ability to handle some pretty specific tasks. Let me break that down together. You'll need to apply specialized data classifications and AWS data protection mechanisms. Implement data encryption methods and the right AWS encryption tools. Set up AWS mechanisms for secure internet protocols. Use AWS security services and features to keep production environments locked down. Make smart decisions that balance cost, security, and deployment complexity for application requirements, and really understand security operations and risks. You might be wondering, who is this exam actually for? AWS says the target candidate should have around 3 to 5 years of experience securing cloud solutions. That's the sweet spot. They want people who've been in the trenches. Now let's talk about the knowledge you should already have coming in. This isn't stuff you'll learn overnight. You need a solid grasp of the AWS shared responsibility model and how it applies in practice. Things like managing identity at scale, multi-account governance, handling software supply chain risks, security incident prevention and response strategies, vulnerability management in the cloud, developing firewall rules for layers 3 through 7, root cause analysis for incidents, responding to audits, logging and monitoring strategies, data encryption for at-rest and in-transit, and disaster recovery controls like backups. So, what does this really mean for you? If you're missing some of these, don't panic. It's a great checklist to focus your prep. Build up that foundation first. On the flip side, there are things that are totally out of scope. You won't be tested on them, so don't waste time stressing. For example, you're not expected to design cryptographic algorithms from scratch, analyze traffic at the packet level, architect entire cloud deployments, manage end-user compute resources, or train machine learning models. That's a relief, right? Focus on AWS-specific security depth instead. Let's shift gears to the exam itself. How does it actually work? The exam throws a mix of question types at you to keep things interesting and challenging. There are multiple choice questions where there's one correct answer and 3 distractors. Multiple response questions which need 2 or more correct answers out of 5 or more options. Ordering questions where you have to put 3 to 5 steps in the right sequence for a task. And matching questions where you pair up responses with 3 to 7 prompts. You've got to get all pairs right. Important tip. There are 50 scored questions, plus 15 unscored ones that AWS uses for future exams. They're mixed in, so you won't know which are which. Unanswered questions count as wrong, and there's no penalty for guessing, so always pick something. Scoring is pass or fail on a scale of 100 to 1,000. You need at least 750 to pass. It's compensatory, meaning you don't have to pass each section individually, just the overall exam. Your score report will break down performance by domain to show strengths and weaknesses. Now, let's look into the content domains and their weightings. These tell you where to spend your study time. Domain 1, detection, 16% of the scored content. Domain 2, incident response, 14%. Domain 3, infrastructure security, 18%. Domain 4, identity and access management, a big one at 20%. Domain 5, data protection, 18%. Domain 6, security foundations and governance, 14%. See how IAM and data protection take up a huge chunk? That's where a lot of questions will come from. Detection and incident response are separate now, which makes sense with the updates. They've got more emphasis on real-world response capabilities. The guide mentions referring to Appendix A for in-scope and out-of-scope services, so definitely check the official PDF for that list. All right, wrapping this up. What does all this mean for your prep? This exam guide is your roadmap. Print it out, highlight the domains, and align your study plan to those weightings. Focus on hands-on practice because this cert is all about applying knowledge, not just memorizing. If you're going for it, you've got this. It's tough, but passing feels amazing and really levels up your career in cloud security. Now let's look at Domain 1, Detection Overview. This makes up about 16% of your scored questions, so it's solid real estate on the exam. Detection is all about spotting bad stuff early. Think monitoring, alerting, logging, and making sure nothing sneaky slips through the cracks. You might be wondering, why does AWS even separate detection from incident response now? Great question. In the new SCS-C03, they split them to really emphasize proactive catching of threats before they blow up into full incidents. So let's walk through this domain step by step, just like we're building a security operations setup together. I'll show you what AWS expects, the key services, and most importantly, how to actually prepare so you crush this section. First up, the big picture. Domain 1 has 3 main tasks: designing and implementing monitoring and alerting solutions, building proper logging pipelines, and troubleshooting when things go wrong with your detection tools. Sound familiar? It's exactly what you do in a real SOC or security team. Let's start with task 1.1, designing monitoring and alerting. Hang on, because this part's super important. AWS wants you to analyze your workloads and figure out what actually needs monitoring. Not everything, right? Then you design strategies like health checks, aggregate all those security events from different places, and set up metrics, alerts, and dashboards. The stars here are services like Amazon GuardDuty for threat detection, Security Lake for centralized storage, Security Hub as your control tower for findings, and Masi if you're worried about sensitive data leaking. Oh, and don't sleep on automating regular checks. Think AWS config conformance packs or Security Hub automated remediations with Systems Manager. So what does this really mean for you? In the exam, expect scenarios where you're in a multi-account organization and need to decide how to roll out GuardDuty across everything or build a dashboard that actually catches anomalies. My tip, go into your AWS console right now. Enable GuardDuty in a test account, play with findings in Security Hub, and set up some basic alerts in CloudWatch. Hands-on is gold here. Now moving smoothly into task 1.2, logging solutions. This one's huge because without good logs, you're flying blind. You need to pick the right sources, configure them properly, like setting up an organization-wide CloudTrail trail or a dedicated CloudWatch logs account, and then store everything smartly. Security Lake is the new hotness for building log data lakes that play nice with tools like Athena for querying. You'll also configure stuff like VPC flow logs, transit gateway flow logs, or Route 53 resolver logs, depending on the network threats you're worried about. Then comes analysis, CloudWatch logs insights. Athena queries, maybe OpenSearch for searching and visualizing, or even Lambda to normalize and correlate logs across sources. Let's break that down together. Imagine an attacker doing lateral movement. You'd want VPC flow logs to catch weird traffic, CloudTrail to see API calls, and everything funneled into Security Lake so you can query it fast. Practice this. Create a CloudTrail org trail, enable VPC flow logs, push them to Security Lake, and run some Athena queries. Trust me, when you see it working, it clicks. All right, last task, 1.3, troubleshooting. Now this one's really interesting because exams love "why is this not working" questions. You'll analyze permissions, configurations, like why your Lambda isn't logging or CloudFront logs are missing or the CloudWatch agent on EC2 is misconfigured. Then fix it. Common culprits: IAM permissions blocking log delivery, agents not installed right, or just plain wrong settings. Pro tip: AWS has killer troubleshooting guides in their docs. Read them. And simulate issues in your lab. Break the CloudWatch agent on purpose, then fix it. You'll thank me when you spot the exact symptom on exam day. So how do you actually prepare for all this? Spend at least 15 to 20% of your study time here. It matches the weighting. Start with the official AWS Skill Builder exam prep course. They have labs. Then hit the free tier hard. Build a mini detection setup with Guard Duty, Security Hub, CloudTrail, and Security Lake. Practice exams from Udemy, link in description, are fantastic. They have tons of detection scenarios, and always read the Repost Knowledge Center articles on logging and monitoring. Wrapping this up, Domain 1 is where theory meets real-world security engineering. Master these tasks, and not only will you nail 16% of the exam, but you'll actually feel confident building detection in your day job. Detection feeds right into incident response, which we'll cover next, so getting this solid sets you up perfectly. Now let's look at Domain 2, Incident Response Now. This one's only 14% of the exam, but let me tell you, it's where the rubber meets the road. Detection spots the problem, but incident response is what you actually do when things hit the fan. If you've ever wondered how real security teams handle breaches, compromises, or attacks in AWS, this domain is it. So grab a coffee and let's walk through it together like we're planning a response to a live incident. First things first, the big picture. Domain 2 splits into two main tasks: designing and testing your incident response plan up front, and then actually responding when a security event pops off. AWS is basically saying, be prepared and know how to act fast and smart. Let's start with task 2.1, designing and testing the plan. Hang on, because this part's super important. You can't just wing it in a real incident. You need runbooks, playbooks, whatever you call them, that spell out exactly who does what. AWS loves Systems Manager Ops Center for centralizing investigations, or even SageMaker notebooks if you're doing some AI-powered analysis. But it's not just writing documents. You have to prepare your environment, provision the right access ahead of time, deploy security tools, minimize blast radius with things like separate accounts or VPCs, and set up protections like AWS Shield Advanced for DDoS scenarios. Then comes testing, my favorite part. How do you know your plan actually works if you never practice? AWS gives you cool tools like Fault Injection Simulator, FIS, to deliberately break things in a controlled way, or Resilience Hub to assess how tough your setup really is. And automation? Huge. Use Systems Manager, Step Functions, Lambda, or even the Automated Forensics Orchestrator for EC2 to make remediation happen without humans slowing things down. Application Recovery Controller for quick failovers. Get familiar with these. So, what does this really mean for you? In the lab, build a simple runbook in Ops Center, trigger a fake incident with FIS, and automate something basic with Lambda and Event Bridge. Trust me, when you see it work, you'll feel way more confident on exam day. Now, sliding right into task 2.2, responding to actual security events. First, preserve evidence. Capture and store logs as forensic artifacts. Don't touch the compromised resource if you can help it. Then investigate. Search and correlate logs across everything. Security Lake from Domain 1 shines here. Validate those findings from Guard Duty or Security Hub so you know it's not a false positive, and figure out the scope and impact. You might be wondering, okay, now what? Containment. Isolate the threat fast, change security groups, block with NetGulls or network firewall, disable access keys, quarantine instances, eradicate, wipe out the bad stuff, then recover. Restore from clean backups, use DRC for quick switchover. Finally, root cause analysis. Amazon Detective is your best friend here. It builds those beautiful graphs showing how the attacker moved, what they touched, timelines, everything. Exam questions often give you a detective graph scenario and ask what happened or what's next. Let's break that down together. Imagine a Guard Duty finding for crypto mining. You jump to Detective, see the EC2 instance making weird outbound connections, trace back to a compromised IAM role from a suspicious login, boom, root cause. Preparation-wise, read the AWS Security Incident Response white paper. It's gold. Do the official AWS workshop on incident response. It's free and hands-on. Enable Detective in your account. Play with investigation graphs. Simulate containment. Spin up an EC2, compromise it, then isolate it with security group changes. Think in phases. Preparation, identification, containment, eradication, recovery. Lessons learned. Practice questions that start with you receive a high-severity guard duty finding. Know the exact next steps. The exam loves testing if you jump ahead too soon, like recovering before containing. Common traps, forgetting to validate findings, not preserving forensics, or choosing manual fixes when automation exists. Wrapping this up, Domain 2 is only 4%, but it connects everything. Your detection feeds straight into response, and good response prevents small issues from becoming disasters. Spend about 12 to 15% of your study time here, but make it count with labs and scenarios. If you're prepping for SCS-C03, you're building skills that companies desperately need right now. Incident response isn't just exam stuff, it's career-changing knowledge. Okay, and so now let's get down to Domain 3, infrastructure security. Infrastructure security is all about locking down the edges, hardening your compute stuff, and controlling network traffic like a pro. Think of it as building multiple walls around your castle. Let's walk through it together, step by step, and I'll show you exactly how to prep so these questions feel straightforward. First, the overview. Domain 3 has 3 big tasks: protecting the network edge like CloudFront and WAF, securing your compute workloads, EC2, containers, Lambda, and designing solid network controls inside your VPCs and beyond. It's defense in depth, edge first, then internal network, then the hosts themselves. Let's kick off with task 3.1, network edge security. Anyone with public-facing apps, you're dealing with threats like OWASP, Top 10, DDoS, bots, you name it, .docs. You select strategies, implement WAF rules, CloudFront security headers, Shield Advanced, rate limiting, geo-blocking, even integrate third-party rules. Practice this. Go create a WAF web ACL, attach managed rules for OWASP, add a rate-based rule to block brute force. It'll click fast. Now, flowing right into task 3.2, securing compute workloads. This one's really interesting because it's where a lot of people leave gaps. You harden AMIs with Image Builder, use proper IAM roles, instance profiles only what's needed, scan everything with Inspector, automate patching via SSM Patch Manager, and lock down access with Session Manager or Instance Connect. Don't forget runtime monitoring with Guard Duty and GenAI protections if you're using LLMs. Lab tip, build a pipeline that creates a golden AMI, scans it with Inspector, and only allows Session Manager access. No bastions, no keys. Finally, task 3.3, network security controls inside and between networks. Security groups, NACLs, network firewall for deep packet inspection, segment east-west traffic with isolated subnets, secure hybrid connections with site-to-site VPN or direct connect, MACsec for encryption, and use tools like Network Access Analyzer or Inspector Reachability to find over-permissive rules. Hands-on gold, deploy network firewall in a VPC, run Access Analyzer, and clean up findings. So, what does this really mean for you? Spend 18 to 20% of your study time here. Do the official AWS workshops on WAF, Inspector, and Network Firewall. Read the well-architected security pillar, know OWASP and GenAI top 10 risks. Build a full layered setup in your free tier. Edge with WAF Shield, Network Firewall, tight SGs, hardened EC2 with session common traps. Mixing up stateful SGs versus stateless, forgetting runtime versus static scanning, or not thinking defense in depth. Wrapping up, Domain 3 ties everything together. Master these layers and you'll not only pass more questions, but build actually secure architectures. For practice exams, focus hard on those multi-choice scenarios, like what's the best way to block SQL injection at the edge? Or how do you harden this EC2 fleet? Now, this one's really interesting. Your study strategy should be 70% labs. Seriously, build that layered protection yourself. Start with WAF in front of CloudFront, then network firewall in the VPC, tight security groups, and finally hardened EC2 instances. Visualize architectures by drawing VPC flows and edge protections on paper or in a tool. It helps so much when exam scenarios throw complex diagrams at you. Time allocation? Give this domain 18 to 20% of your total prep. It overlaps beautifully with data protection next, like encryption in transit at the edge. We will now cruise through Domain 4, Identity and Access Management. IAM is literally the gatekeeper of everything in AWS, who gets in and what they can touch. Let's hang out and go through it like we're designing a secure setup together. So the domain splits into 2 main tasks: authentication, figuring out who you really are, and authorization, what you're actually allowed to do once you're in. Starting with task 4.1, authentication strategies. AWS wants you to design solid ways for humans, apps, and systems to prove their identity. Think IAM Identity Center for your workforce. It's the modern way to do single sign-on across AWS accounts and apps. with federation to external IDPs like Okta or Azure AD, plus mandatory MFA. For customer-facing apps, that's Amazon Cognito territory. User pools, sign up, sign in, all that good stuff. Then temporary creds, STS for assume role, roles anywhere if you've got workloads outside AWS that need to grab role credentials securely, or presigned URLs for direct S3 access without keys. Troubleshooting? Dig into CloudTrail for auth events, check permission sets in Identity Center, or directory service connections. You might be wondering, when do I pick Identity Center over Cognito? Simple, workforce versus customers. Lab it up. Set up Identity Center with an external IDP, enforce MFA, and federate into a few accounts. It'll make those scenarios crystal clear. Now, sliding into task 4.2, authorization. This one's really interesting because it's where least privilege lives or dies. You design controls using things like verified permissions for fine-grained app-level auth, IAM paths for organizing principals, roles anywhere again, resource-based policies for cross-account stuff, and tight trust policies on roles. Big shift to ABAC, attribute-based access control, using tags or attributes to make policies dynamic and scalable instead of static RBAC roles everywhere. Write policies with least privilege in mind. Permission boundaries to cap what a role can do no matter what. Session policies when assuming roles to temporarily restrict. SCPs and organizations to guardrail everything. Then the detective side. Use IAM Policy Simulator to test will this work before attaching, and IAM Access Analyzer to scan for unintended access, like public resources or external principals that shouldn't be there. So what does this really mean for you? Exam questions love giving you a policy and asking why access is denied, or spotting over-permissive trust relationships, or fixing Access Analyzer findings. Practice daily. Write tag-based ABAC policies, like allow EC2 start-stop only if the instance has a tag matching the user's department. Use the policy simulator constantly, run Access Analyzer on your accounts, and remediate whatever it flags. Common traps. Mixing up identity policies who can assume versus resource policies who can touch this bucket, forgetting that SCPs block even root, or not using session policies for short-lived restrictions. Let's break that down together. Imagine a cross-account scenario. The trusting account needs a proper role trust policy. The trusted account attaches a policy allowing the assume, and maybe a resource policy on the target if needed. Draw those trust flows on paper. It helps so much. Prep tips. Give this domain 20 to 25% of your time. Hit the official AWS Skill Builder IAM labs, do the IAM best practices and Access Analyzer workshops, read the IAM best practices white paper. Build a multi-account org with Identity Center, ABAC everywhere, and run Access Analyzer regularly. Domain 5, data protection domain, carries around 18% of your score. That's nearly a fifth of the exam. So mastering it gives you a serious boost. AWS wants to make sure you can protect data in every state, whether it's moving across the network, sitting quietly at rest, or being replicated for backup. You'll see questions about encryption, key management, backups, secrets, and even ransomware scenarios across multiple accounts or regions. And yes, most of these are scenario-based, not just definitions. So what's the exam really testing? Basically, it wants to see if you can make the right choices, which encryption method to use, who manages the keys, and whether your data access is public, private, or hybrid. Hang on, because this part's super important. Always ask yourself those 3 questions when tackling Domain 5 questions. And a quick prep tip. Spend about 15 to 18% of your study time here, but focus on labs over theory. Build it, break it, and fix it. That's how it really clicks. All right, let's move into task 5.1, data protection in transit. You might be wondering why this is such a big deal. Well, data is most vulnerable when it's moving. That's why AWS wants you to enforce TLS everywhere, from the edge, between services, and even between nodes inside clusters. Key services to remember: ELB security policies. Make sure TLS 1.2 or higher is enforced and cipher suites are modern. CloudFront HTTPS only is another classic. And for private connectivity, AWS loves Private Link, VPC endpoints, client VPN, and verified access, especially when they don't want traffic going over the public internet. Inter-service encryption is another one to practice. EMR internode encryption, EKS, MTLS between pods, SageMaker training and inference encryption, and Nitro-based in-transit encryption. Here's a little example. Imagine a finance application that must ensure traffic never touches the public internet. The right choice? Interface VPC endpoint plus private link plus TLS enforcement. Hands-on prep is crucial. Enable HTTPS only ALB, create a VPC endpoint, and inspect TLS policies on ALB or CloudFront. Now let's slide into task 5.2, data at rest. Here, the exam wants you to choose the right encryption strategy and manage data integrity. Encryption options include AWS KMS, which is default and scalable, or Cloud HSM, which is compliance-driven. Don't forget client-side versus server-side encryption. For immutability, think S3 object lock, Glacier Vault lock, versioning, or even code signing. Lifecycle and retention are important too. S3 lifecycle rules, EFS lifecycle policies, FSX backup retention, and for backups and replication, AWS Backup, Data Lifecycle Manager, cross-region replication, and ransomware recovery patterns are your friends. Here's a scenario. Data must be immutable for 7 years due to regulations. The correct choice? S3 object lock in compliance mode plus KMS CMK. Hands-on tip, enable default encryption on S3, create lifecycle rules, and test object lock behavior. Now let's tackle task 5.3, which is all about secrets, credentials, and keys. First, AWS Secrets Manager, rotation, audit, automatic refresh, no hard-coded secrets ever. Key material options include AWS-generated KMS keys, imported keys, BYOK, or external key stores, XKS. Know the differences. AWS-generated keys are easiest, imported keys give you compliance control, and external keys never leave your HSM. Don't forget sensitive data masking, like CloudWatch logs, data protection, and SNS message data. Certificates and PKI are also tested, AWS Private CA and multi-region key strategies. For example, if a company requires full control over key lifecycle, your answer should be imported key material or external key store. Hands-on prep? Store and rotate secrets, import key material into KMS, and apply log masking policies. So what does this look like on exam day? AWS loves asking things like, which option provides the most secure solution? Which option meets compliance with least operational overhead? Which solution prevents public exposure? High-frequency traps include choosing encryption but forgetting key ownership, using public endpoints instead of private link, or enabling encryption while logs or secrets are exposed. Remember to think in layers. In transit, TLS plus private connectivity. At rest, encryption plus integrity lifecycle. Secrets, rotation, least privilege. Last but not least, let's talk prep strategy. Spend 70% of your time on labs, 30% on reading and practice exams. Must-do labs include HTTPS only ALB plus TLS policy, private link plus VPC endpoint, S3 object lock plus lifecycle, AWS backup policy, secrets manager rotation, and imported KMS keys. Recommended reading is AWS encryption white paper, KMS best practices, and AWS backup and ransomware guidance. Domain 5 is about making smart trade-offs between security, compliance, and operation. Now let's deep dive into Domain 6, Security Foundations and Governance. In this domain, AWS tests how you build secure, scalable environments from the ground up. Think multi-account strategies, compliance checks, and making sure everything's locked down tight. We'll cover the key tasks, how to prep, and some insider tips to make studying fun and effective. Let's jump right in. First off, let's get a big picture view of Domain 6. It's all about laying those strong security foundations and keeping governance in check. You've got 3 main tasks here: centrally deploying and managing AWS accounts, implementing secure deployment strategies for resources, and evaluating compliance. This domain is probably 15 to 20% of your exam, so it's huge. It's where AWS wants to see you thinking like a pro security architect. Why does it matter? Well, in real-world setups, especially big enterprises, you can't just wing it with one account. You need structure to avoid chaos. For prep, start by understanding AWS best practices for landing zones. Grab your free tier account and set up a simple multi-account org to get hands-on. Aim for 10 to 15 hours here, hitting the official docs and white papers. You might be wondering, where do I even begin? Trust me, once you play around with it, it'll click. Now let's zoom in on task 6.1, developing a strategy to centrally deploy and manage AWS accounts. This is the backbone. Skills like deploying AWS organizations, configuring control tower, implementing policies like SCPs and RCPs, setting up delegated admins for security services, and handling root user credentials with MFA and break glass procedures. Hang on, because this part's super important if you're dealing with multiple teams or compliance-heavy environments. To learn this effectively, dive into the AWS Organizations User Guide and Control Tower docs first. They're gold. Then get practical. Hop into the console, create an organization, slap on some SCPs to test denying actions, and simulate a control tower setup in a sandbox. Practice delegating admins for stuff like guard duty. It's a game changer for central management. Key tip, really focus on how policies inherit and handle exceptions. That's where a lot of exam questions trip people up. And don't forget root security. Think vaults and emergency access. Courses like A Cloud Guru have great labs for this. Common mistake? Forgetting SCPs, don't touch the root or management account. Nail this and you'll feel way more confident. All right, moving on to task 6.2, implementing a secure and consistent deployment strategy for cloud resources. This one's really interesting because it's all about repeatability and security at scale. Skills include using IAC like CloudFormation stack sets or even Terraform for cross-account deploys, tagging resources smartly, say by department or environment, to make management a breeze, enforcing policies centrally with Firewall Manager, and sharing resources securely via Service Catalog or AWS RAM. So what does this really mean for you? It means no more manual messes. Everything's automated and auditable. For prep, check out the CloudFormation docs and tagging best practices white paper. Hands-on is key. Deploy a stack set across a couple of accounts, tag some EC2 instances via API, share a VPC with RAM, and build a service catalog portfolio. Pro tip, always scan your IAC with tools like CFNLint or Guard for consistency. Exam-wise, Adrian Cantrell's course has killer labs here. Watch out for pitfalls like skipping cross-account IAM roles in IAC or mixing up RAM with other sharing services. Practice those scenarios and you'll ace it. Let's break down task 6.3 next. Evaluating the compliance of AWS resources. This is where you prove you can spot and fix issues before they bite. Core skills? Creating AWS config rules to detect and remediate non-compliant stuff, integrating with Security Hub for alerts, using Audit Manager and Artifact to gather evidence, and running architecture reviews with the well-architected tool. You might be wondering why this happens in security certs. It's because compliance isn't just checkboxes, it's ongoing vigilance. To prepare, start with the AWS Config Developer Guide and Audit Manager docs. Get dirty with labs. Set up config rules that trigger Lambda remediations, run an Audit Manager assessment, and do a full well-architected review on a dummy workload. Focus on multi-account aggregation in config. That's a hot topic. Quick Labs has free sessions for config and Security Hub integration. Practice exporting evidence for audits like PCI or HIPAA. Avoid the trap of ignoring config aggregators for org-wide views or overlooking custom lenses in well-architected. This task ties everything together, so revisit it after the others. Finally, some general prep tips to wrap this up. Build a study plan. 1 to 2 weeks for Domain 6, blending theory from docs with labs. Use your free tier wisely. It's perfect for testing without costs. Hit practice exams from AWS, Plug-i, link in description, and Udemy. Shoot for 80% or higher on Domain 6 questions. Top resources, official AWS Security Specialty Learning Path, repost blogs, and the AWS Security blog for fresh updates. Books like the AWS Certified Security Study Guide are solid too. Join forums like AWS Community for questions. Real pros hang out there. Success secret, always ask why behind the tools, like why SCPs over IAM. Retake labs till it's second nature. There you have it, folks. This domain might seem dense, but break it down like we did, and you'll crush the exam. If this helped, smash that like button, subscribe for more AWS tips, and drop a comment on what domain to tackle next. Thanks for watching.